Hello friends, dear learners and my dear students. First of all, I take an opportunity to welcome you at my TYBSc Analytical Chemistry class. Friends, I am Dr. S.R. LABHADE, working as Associate Professor in Chemistry at ATGM College, Nashik. Student, in previous lecture we discussed technique of ion exchange chromatography. We know that ion exchange chromatography is an adsorption type of chromatography specifically useful for separation of ionic compound using ion exchanger resin as a stationary phase and water as a mobile phase. We also discussed what is the analytical principle involved in separation of ion in ion exchange chromatography. Finally, we discussed the elution process, and in today's lecture we have to discuss the applications of ion exchange chromatography. As we discussed in previous lecture, ion exchange chromatography is useful for separation of ionic compounds. Therefore, specific applications of ion exchange chromatography is a separation of ionic compounds. First application is a separation of metal cations by using anion exchanger resin. Second application is separation of amino acids. And third application is purification of water or deionization of water. Now we discuss each application in detail. First application is separation of metal cation by using anion exchanger resin. Student, we know that cation exchanger resin exchange the cation, anion exchanger resin exchange the anion. How does it possible to separate the metal cation by using anion exchanger resin? Or is there any mistake while writing this title? Therefore, here we have to discuss how the ion exchanger resin is useful for separation of metal cations. In this case, for separation of metal cation, here a complex formation reaction is used. Student, many metal ions including transition and inner transition metals that forms the chloro complexes with chlorine or HCl. Chloro complexes means, for example, we have Fe3+. If we treat this with hydrochloric acid, then it gives FeCl4- and H+. Such a type of complex is called as chloro complex. Here, chloro complex is formed by treatment of metal ion with hydrochloric acid. Here, this chloro complex have negative charge, and therefore here we can utilize this property of chloro complexes for separation of metal ion. In this case, the stability of this chloro complex will depend upon the concentration of hydrochloric acid. If concentration of hydrochloric acid is altered, whether it is decrease or increase, then that particular chloro complex is get break or it get disturbed. If chloro complex of that particular ion is break, it is immediately converted into its cation. And therefore here, by changing the concentration of the H+ ion or hydrochloric acid, we can carry out the elution process of this separated ion. Now many metals including transition, inner transition metals, hydrochloric acid forms the chloro complexes with this ion. Hydrochloric acid does not form the chloro complex with chromium 3+, then Al3+, then alkali and alkaline earth metal. Alkali and alkaline earth metals does not form chloro complex, including nickel. Nickel also does not form a chloro complex. Therefore, chromium 3+, aluminum 3+, nickel 3+, alkali means sodium, potassium, lithium, calcium, alkaline earth metals, calcium, magnesium like this. All these metals does not form the chloro complexes with hydrochloric acid, and therefore these ions can be easily separated from those ions which forms the chloro complexes. This property is again useful for separation of chromium, aluminum, nickel and alkaline earth metal from other metals which forms the chloro complex. Now we discuss how the particular application is performed by using a anion exchanger resin. Suppose for example we have mixture of Ni2 plus, nickel 2 plus, manganese 2 plus, Mn 2 plus, then cobalt 2 plus, then copper 2 plus and Fe3 plus and zinc plus, zinc 2 plus. We have all these metal ion in a mixture including nickel. As I told you, nickel does not form a chloro complex, therefore we can easily separate this nickel from these other metals which forms the chloro complex. Now how to perform this experiment? Initially this mixture is treated with 12 molar hydrochloric acid. That means sample is dissolved into 12 molar hydrochloric acid. Then we have to prepare the column of anion exchanger resin, and this column we have to add this mixture of metal ion in a 12 molar HCl. As we know that here at this 12 molar HCl concentration, all other metal ion except nickel from the chloro complex. Therefore, nickel will be remains as a nickel 2 plus, while all other ions are get converted into their chloro complex. When we pass this mixture through this anion exchanger resin, strong base anion exchanger resin, when we pass this mixture through this anion exchanger resin does not exchange this nickel cation, and therefore nickel will be directly given out from the solution or from the column as we add or as we load the sample, because that is not converted into its chloro complex. It is present in a cationic form. Cationic form does not adsorb on the anion exchanger resin, therefore it directly given out through the column. Therefore, we can, after loading the sample, we have to carry out the elution process by means of 12 molar HCl where nickel is get eluted. Therefore, elution of nickel is carried out by washing the column with 10 molar HCl or 12 molar HCl, because nickel does not form the chloro complex with chlorine or with hydrochloric acid. After that, if we decrease the concentration of this hydrochloric acid up to 6 molar, then at this 6 molar concentration, manganese chloro complex is get break. Because manganese will form a chloro complex with hydrochloric acid when concentration is greater than 6 molar. When we reduce the concentration up to 6 molar, then Mn2 plus is get eluted. Mn2 plus eluted. And if we decrease or if we wash the column by changing the concentration of hydrochloric acid up to 4 mole, then cobalt 2 plus is eluted. Up to 2.5 mole, then copper will be eluted. Up to 0.5 mole, then Fe3 plus will be eluted. If we decrease the concentration 0.005 moles, then zinc 2 plus will be eluted. That means here this is a concentration to which these chloro complexes are stable. Therefore, manganese will be form its chloro complex when concentration is greater than 6 molar. Cobalt will form its chloro complex when concentration of hydrochloric acid is greater than 4 molar. And at lowest concentration, zinc will form the chloro complex. Therefore, here we have to disturb the stability of that chloro complex by changing the concentration of hydrochloric acid during the elution process. Therefore, elution process is carried out by decreasing the concentration of H plus ion. In this way, we can selectively separate all these ions by using an anion exchanger resin. The second application of ion exchange chromatography is the separation of amino acids. Amino acids are amphiteric in nature. That means amino acid can donate H plus ion and amino acid can take H plus ion. Therefore, amino acids are amphiteric in nature. Therefore, by changing the pH, we can convert amino acid in cationic form as well as in anionic form. And therefore, we can easily convert this amino acid as an ionic compound by changing the pH. Amino acid have a general formula. This is RCHCOO minus H plus and here NH3 plus. Here this amino acid is treated with H plus ion. Therefore, here if we remove the H plus ion, then here we have RCHCOO minus and NH3 plus. H plus ion is removed. Again, if we remove another H plus ion, then we have RCHCOO minus and NH2. In this case, this form of amino acid have extra H plus or extra plus 1 charge. This form is called as X form, which is a cationic form. That means having a plus 1 charge extra. This ion have no extra charge. Total charge on this molecule is 0. This is called as Y form or a Zwitter ion form. Zwitter ion form. Zwitter ion form, that is a form where net positive and negative charge on the ion or that particular molecule is 0. This will be the amino acid having form, that is Z form, and here it is a basic form or a anionic form. Therefore, here if we change the pH of solution minus H plus, if we change the pH of solution, we can convert that amino acid into cationic form or into anionic form or into Zwitter ion form. The pH, that is the concentration of H plus ion, the pH at which the net positive and negative charge on a particular amino acid is 0, that pH is called as isoelectric point. Isoelectric point is the pH at which the net positive charge, net charge on the amino acid is 0. It acts as a Zwitter ion form. That is, positive charge equal to negative charge present in the molecule, and it acts as a Zwitter ion form. That means no charge is present on that particular ion. Therefore, here if we have mixture of amino acids, then all those amino acids initially treated with a H plus ion, and those are separated on the basis of their isoelectric point. That means all amino acids are separated on the basis or by forming their Zwitter ion form. A pH is identified. To that pH, that particular amino acid is converted into Zwitter ion form. Therefore, amino acids are initially separated on the basis of their isoelectric point, that is a pH at which net positive and negative charge on the amino acids are 0. After that, this amino acid is is treated with, that is mixture of 2 or more amino acid that is treated with H plus ion. At that particular pH, if there are 3 amino acids, then one amino acid may get converted into cationic form, one amino acid at that pH is get converted into anionic form, and sometimes another amino acid may be present in a zwitter ion form. Therefore, we have 3 amino acids in a different form. One is cationic form, one is anionic form, and third is zwitter ion form. If we pass mixture of such a 3 amino acid through initially first cation exchanger resin, then this cationic form is exchanged on a cation exchanger resin. Then same solution if we pass through anion exchanger resin, then anionic form will be exchanged on anion exchanger resin, and finally the zwitter ion form that cannot be exchanged on cation exchanger resin or anion exchanger resin, that will be directly given out. That means this form will be adsorbed on a cation exchanger resin, this form will be adsorbed on a anion exchanger resin, and zwitter ion will be get eluted with the solvent. In this way we can separate these 3 amino acids by using a cation exchanger resin and anion exchanger resin. After that, once those are separated, we can carry out elution of those amino acids by changing the pH. Again, if this form is exchanged on a cation exchanger resin, if we change the pH of solution, then it may be converted into either zwitter ion form or into an anionic form. Zwitter ion form or anionic form is not adsorbed onto the cation exchanger resin. Then elution process is carried out by changing the H plus ion concentration or by changing the pH of solution. Similarly here, if this form is present on anion exchanger resin, if we change the pH, it gets converted into a cation exchanger cationic form or zwitter ion form. Therefore, once it converted into cationic form, it will be not adsorbed on the anion exchanger resin. In this way, elution process is carried out by changing the pH of the solution. In this way, amino acids are separated by using anion exchanger resin and cation exchanger resin. Next application of a ion chromatography is a purification of water or deionization of water. Ion exchange chromatography have a great application in separation of ionic compound, and that application is also useful for deionization of water. The removal of ions from the water that can be done by using a anion or cation exchanger resin. Suppose for example, we have a water that containing calcium chloride as a dissolved salt. Therefore, initially we have to pass that water through a strong acid cation exchanger resin in H plus ion form, where calcium ion are get exchanged, that is ReSO3 minus H plus means twice Ca2 plus 2H plus. That means single calcium ion is get exchanged with 2 resin molecule, ReSO3 minus twice and Ca2 plus. Similarly, 2 chloride ion, when we pass through a resin molecule containing a NH3 plus OH minus amine group, then it is get converted as a ReNH3 plus Cl minus NH3 plus Cl minus twice plus 2 OH minus ions are given in the solution. In this case, when we pass that water containing dissolved salt through mixed bed of cation exchanger resin and anion exchanger resin, cation will be exchanged on a cation exchanger resin in this form, and anion will be exchanged on anion exchanger resin by giving a OH minus ion. The H plus ion release in this exchange process, and OH minus ion released in this process gives 2 water molecule. Therefore, single calcium chloride molecule is exchanged with 2 H2O molecule, and hence we can remove the IS from the water, and that is called as deionization of water. Ultra pure water that can be obtained by this deionization process, and ion exchanger resin have great application in deionization process. Student, these are the 3 important applications of ion exchange chromatography. Separation of metal cation by using anion exchanger resin, separation of amino acids, purification or deionization of water. Student, you can find out the answers of following questions. Number 1, what is ion chromatography? Number 2, what is stationary phase in ion chromatography? Number 3, give the classification of stationary phase in ion chromatography. Number 4, explain the separation principle involved in ion chromatography or mechanism of separation in ion chromatography. How does elution is carried out in ion chromatography, and give the different analytical applications of ion exchange chromatography. Student, based on previous discussion and today's discussion, you can find out the answers of this question. In forthcoming lecture, we discuss the technique of gas chromatography, that is a versatile method of chromatographic analysis useful for identification and estimation of gaseous and volatile samples. With this, I wish you all the best. Thanks for joining me. Keep learning.